if I am talking about word problems, so strategies for word problems, we are going to talk about, first of all, the types of word problems. Have you seen this document here? So this document is really good. It comes out of the back of our standards. So if you go to kystandards.org, in the back, there's an appendix section and it has the word problems. Now, typically what happens in word problems, typically what we have is, especially with addition and subtraction, we have what we call result unknown. We have add to, take from. So add to means I've got the number and I'm adding to it, right? So I have two bunnies that sat on the grass and then more bunnies hopped in there. And so I've got that number and I'm adding to it, right? That's what that is. With change unknown, it means that the second number is unknown, and start unknown means the first one. I had some bunnies and some more hopped in, and now I know how many total I have. What happens that we do, and also we've all been guilty of it. I don't care what happens. We end up being guilty of it. And I have had teachers who I said, okay, write down an addition problem or a subtraction problem, and that you typically give your kids. When they go to put it on here, it's typically right through here, right? We sometimes get this put together and take apart, but the problem with that is when we go to take the state test or later on, the types of questions they're asked to do are down here. So we actually have a put together, take apart that should be both add-ins unknown, where they're kind of filling in, or add-in unknown, or they should be a compare. And any of these compares are really good. So you need to kind of look at these to get a gauge on what you want to use. So I would suggest going to your kystandards.org, looking at that. Now, if you're doing multiplication, of course, in multiplication, it's the same thing. We have unknown product, group size, unknown, and we have number of groups unknown. We also have equal groups, arrays, and compare. Again, we tend to give them problems that look like this when they need to be working through problems that look like these. So if you go to, like I said, your standards, this is in the back. It's a great resource for us to have to kind of know what kind of problems am I giving my students, and am I really hitting the rigor that they need. That's the issue that we run into. Text comprehension in mathematics refers to the way that we decode the meaning of words. Now, too many times when we're doing word problems, we teach them keywords, right? Left means subtract. We talk about groups always being multiplication. That's not true when it comes to that. We got to really make sure that they understand the relationship and they have some kind of representation that goes with those problems. So we need to start creating mental, either a mental representation so that they can see what's happening in the problem. And we're going to talk about that today and how we do that. Or we need to make sure that they can translate the terms and they know what's being asked in the problem. So we're going to do that. So we want to mathematize word problems. We want to make sure, what are they noticing? That's going to be the first thing, right? What are they noticing that's going to allow them to know what's going on in the word problem? Number two, are they exploring the word problem? Can they break that problem apart and say, this is what's happening? Are they explaining it? Are we having enough discourse, not just between you and the students, but also between the students? And then, of course, modeling. Can they model that problem? If I give them strips of paper, if I give them, trying to think, number bonds, they have number bonds if they're doing addition and subtraction in the lower grades, can they at some point model this problem? And then also, can they argue with you about why they're right or about why something is wrong? And then also, if you notice in each one of these, that modes of representation that we're going to look at, and these are my three favorite, I'm going to be honest, but verbal, contextual, and then concrete, picture, and symbolic. We call this the CSA model, concrete, semi-concrete, because they're drawing it out, right? And then this is symbolic, where they're only doing the numerals. So, and the signs. So if we look at this, I really want them to have all those opportunities when they're working through a word problem. I want them to have that opportunity to have concrete manipulatives that they're going to work with, whether it's a bead string, unifix cubes, whatever it may be. My favorite, if they're working with multiplication, is the Quizner rods. That's a really good one. And I don't put numbers on those because I want them to start to work with them. So multiplication, like I said, Quizner rods are great for that. One of the things that, and this is a longer one, and this is actually by Charles Forston, is the step-by-step model diagram. Children have to be able to, or we need to, read the entire problem to them. That's the first step in that, right? We read that problem, we have those conversations about what's happening in the problem. Many times kids will get stuck. Our kids that are in special ed, they'll get stuck on the name. They're all excited about that name that's in there. So I try to sometimes when we've got books and those kind of things that have problems, change the names up for them. If I'm putting it up and being presented. If it's somebody who's, you know, an easier name for them to read, like Bill. If we know they're going to get hung up on them, I'll change the name real quick. They need to rewrite the question and they need to put it into a sentence form. Many times this will help our students, if they're doing this, to remember if that, especially for older kids, if it needs to have inches added to it, if it needs to have, because they'll say it needs to be, you know, the answer needs to be done in inches, right? Or they'll remember those kind of things that they need to put on the end. And then also determine who or what is involved in the problem. Sometimes they can't tell you that. So it's a good thing to have opportunities for them to circle or to work through a problem to where they're doing that. And then draw unit bars out. We call them unit bars. We also call them tape diagrams. That's what we're going to talk about today. Having tape diagrams for them to work through. The other thing is that I want them to do is I want them to completely compute and solve the problem. And I want them to answer it back in the sentence. That would be a good way. This is a step-by-step. You can actually look this up with her name. And this is one way of walking through it. Another way that I like is content scaffolding progression. There's a reason I like content scaffolding progression is because it allows us to do the gradual release. Have you heard of explicit instruction? Explicit instruction is Anita Archer's I do, we do, you do. I do meaning I'm going to model it for that student. I'm going to have those conversations out loud that I would typically have in my head. So I'm going to really, truly do a think aloud with this. Okay. So if I've got a problem, I'm going to do a think aloud. And then the other thing is, then we do it together, right? We, as I have those conversations about what do you think is going to happen next? I ask the students, what do they see? What was one thing that I modeled beforehand that we may be doing again in this problem? So that's brought in here. The other thing about content scaffolding progression is it's a gradual release because the last two problems of the content, and it's the same type of problem over and over and over and over again. Now you're going to say, yep, my textbooks do that, right? They do to a point. But the thing about textbooks is they're still the same type of problem with all the information in them. This is going to remove a lot of that, what I call useless information that's put into a word problem that they don't need, that may confuse a child. So we're going to work through that. Now, in this one, the teacher selects the content. It's not distracting. It is not too difficult. I'm going to make sure that it's comfortable for my students to work through. And then from there, I'm going to have them to learn whatever that skill is while they're working the problem. Yes.
We have a comment that says this content scaffolding progression seems to align with the MPS, is that math practices?
Yes.
Especially math practice 4.
Mm-hmm. It does. Also, we are going to focus on the skill that's being taught, a particular skill. And we're going to keep the student from getting stuck and bogged down in all the useless information that's in the problem. So that's what we want to do. And if you want to look this up and get a little bit more information, Paul Riccomini, like I said, I was looking at the summer to actually see him in person and to have some conversations with him about how to use this with like algebra and those kind of things. And that was really good. And you can use this with all areas. So techniques and content scaffolding progression. Number one, it's going to be something that has to be familiar for your students. It has to be high interest. I want to be the first one to say most of our kids love it when we bring stuff in that's happening right there in their school. So a good example is if the kids are planning prom, right? Let's do something around prom, have some questions that's around some of the prom stuff that's going on. And if I was doing maybe an arch, we would talk about that arch that they're going to be walking under. We would do measurements for that. We would have those kind of things going on. It should be easy content, and we start with simpler numbers. I try to work, if I'm working with kids in high school, and this is no joke, if they're in high school and I'm starting to teach algebra, I start out with numbers within 20. I don't want them going outside because they're comfortable with those, right? I can take that, I can break it apart, I can use those. So I start with simple numbers. I want them to understand what's the process. I'm not taking that process away from them in mathematics if I start with simpler numbers and I'm comfortable with it. I remove all that irrelevant information. And then I'm going to include the answer in my problem, because what am I wanting them to focus on? Think about what am I wanting them to focus on? Am I wanting them to focus on getting an answer, or I'm wanting them to focus on the process to the answer? She's looking at me like, I don't know. It's okay.
Well, yeah. And there's a question that says, is he involved with any textbook series or work with people like Jason Zimba?
He's worked with different ones. He is actually now a professor at, I'm trying to think of the college it is, but he worked many years with just special needs kids. So he has done so much research behind what does it take for kids to understand how to obtain math understanding. And so I was extremely impressed with the amount of research that he had put into content scaffolding progression, and how he's changed it over the years because of the way it started out and the way it is now. It's very different. So the other thing that, well, I'm gonna get back to this so you can actually see them. The other thing is I want to include that answer because I want them to see the process. That's what I want. And I want them to get comfortable with the process. And I may teach them 2 or 3 different ways, or 2 or 3 different things that they can use in that process when I'm doing this. Also, I'm going to start with the easy steps. I'm content scaffolding. What's the easiest part that I can do inside that? Then the other thing is I'm going to allow the students, again, I've said this 1,000 times, to focus on that process. But then I want to identify the structure of that word problem. Word problems all have structures. Gradual release is the key to this. And every student has an SDI. One of our SDIs can be gradual release. And so if we're doing gradual release, content scaffolding progression definitely gets into that. Application of the content, we're going to select a word problem type. We're going to rewrite that word problem. I said we. I mean, as a teacher, we're going to rewrite that word problem because I'm going to look at that word problem and I'm going to determine it. I'm going to rewrite that word problem using that scaffolding that I'm going to show you in just a minute. And then we're going to develop the sequence of 3 to 5 problems. Okay. I picked 4 when I did this, but it was only because that's the word problem I was using. I just picked 4 of them. And then I decided, no, you may have a word problem that I need 5 of them to make sure my students are getting it. Instructional scaffolding, this is what you're going to think. You're going to think about the specific steps that we're going to need to work that word problem. So think about all the steps that you're going to need. You may even want to at first color code those steps for that student. That's another SDI that we can have. So if you use highlighters, or just like one of my favorite things for my middle school kids was all the numbers that needed to be, that were negative numbers, were written in red. They just automatically went through and they used a red pencil and they wrote over them in red so they would remember them. It was a good way to make it stand out. It's good visual. So we're going to talk, then I want a model. It's going to be me. I'm going to verbalize my thinking. I'm going to have them, and it's okay to, sometimes we think crazy thoughts when this sounds weird when I'm talking out loud, but it helps the kids and you to process that whole problem. And we may have the students repeat some of the thoughts. What's that step that I just did? Those kind of things, they need to repeat it. And then we're going to answer some questions of why you're doing that step. Now, why am I doing this? What do you think happened that made me want to do this? We use the common, precise academic language. I'm going to throw as much vocabulary as I can at the student. Because, guys, the only place that you're going to see your math language is your math vocabulary is in your math class. Nowhere out here does our kids go and say the word sum, and it actually means that they're adding two things together, right? When they hear the word sum, it's, I want some candy. It can be any number of things, right, for them. So it's not precise. we want to make sure our math vocabulary is there. Gradual release, more of the we do sometimes is needed. As special ed teachers, I want to tell you, I felt like I lived in we do world because they needed that extra help, right? That's okay. Anytime we do explicit instruction, we do content scaffolding, whatever it may be. I'm going to start out with the I do. We're going to do some we do. We may even do some you do at one point. We may realize that we need to move back to the we do. So it's going to be some help. But the key to the we do is the students actually doing quite a bit of the talking. I may be leading them, but the student is the one who's doing the talking. The other thing that we will need to do is we're going to look at the last problem is definitely always a you do. So the you do is the students doing it. They're having those conversations and then we come back to it. All right, so we're going to try one. And the one that I picked this just from a random book that I had a couple of problems in. So it is and I just changed some words in here because it was just buckets of water. But we all know our little boys, most of them like to hunt, right? With their daddies, and they love rabbit hunting. So I used rabbit dogs in this one. So I said, okay, Mike has a couple of buckets of water. He has a total of 3.5 gallons of water to fill his dog's water bowls. Each of the dog's water bowls holds 3/4 gallons of water. How many bowls can Mike fill with water? So if I was going to look at this, how would I content scaffold that problem? Now again, I had the original problem here, right? So in this case, well, it's 8.5 gallons and 1/4 gallon, but it's the same. How much would he need? This is the original problem. And then if I look back, how did I scaffold it? Well, first of all, if you look at the first one, I removed any unnecessary information. There's 5 gallons of water in some buckets, right? Now, each of my bowls holds 1/2 gallon of water, and I am able to fill 10 bowls with water. I put back the answer. I'm using student-friendly numbers, right? So we went from 8.5 and 1 and 1/4. That's kind of hard, right, for our kids to go from halves to fours and see all that. We know that, right? I went back and I changed it. So this, I know I can take 5 gallons. Well, what do we know about the bowls? They're 1/2 gallons, right? So I'd have those conversations with the students. I would be the one talking this through. I would be the one who I'm going, okay, and I would be drawing at this point. So first of all, I would say, what do you see there? No, just tell me what you see in that first problem. Okay, how many gallons do you see there? I have 5 gallons of water, right? So let's talk about 5 gallons of water. I'm going to do this in a type diagram flicker, right? So 1, 2, 3, 4, 5, right? So I got 5 gallons of water. Now, what do we know? Now, if I'm thinking of this, this says each bowl will hold 1/2 gallon. So if this is a whole gallon, my bowl is only going to take 1/2 of that, right? So that means I can divide this in half. So this is one of them, and I've got 2 bowls there, right? Out of that one. And so I can divide this one, and I've got 2 more bowls, correct? And I may even draw some lines here so that we know that those bowls are there. And I'm going to divide this one. I've got 2 more bowls. I'm going to divide this one in half. And I have 2 more bowls. I'm going to divide this one in half. And I've got 2 more bowls. So now I can count my 2s. 2, 4, 6, 8, 10. So I should have 10 bowls. Is that correct? Do you think that's correct? I don't think that is correct. Now let's talk about this. Is that what I've got up there? I am able to fill 10 bowls. That's what it says. So I did get to 10 bowls. So what happened there when I did 5 gallons, but I put it with each in half bowls? What happened actually there with the math? I did. I showed it out by dividing. So I divided each one of those, and we know that 5 times what gives me 10? 5 times 2. But that doesn't make sense with a half. So what does that mean? If it says I divided it by half, what do you think's happening next? Because we divided this by half, didn't we? So we know that we divided it by half, but is there something that I can do there with 5 and a half? With 5 and then the half that I can get that answer? I could. So possibly, if I was looking at this, how could I get to this? This is one way that I could show it, right? But I know that I have 5 gallons and I'm dividing them in half. And anytime I'm dividing them in half, I'm doing what? I'm getting 2 out of those, right? So if I divide it by half and I got 10, we can start talking about what's happening to that problem. And then we can start talking about the fact that 5 is actually times 2 over 1 is equal to 10, can't we? Because we showed it up here. Now, we can have those conversations. In the next one, we're going to have some more harder conversations. Now, in this one, it says similar to the first problem with harder numbers. Now, in this one, there is 6 gallons of water in some buckets, and each of my buckets holds 3/4 gallons of water. It says I'm able to fill 8 bowls with water. Now, let's talk about that. How many gallons did I have? Very similar to this first one. I'm doing a diagram, right? And I've got 6. So 1, 2, 3, 4, 5, 6. This is a big gallon. So now, how many? It says each of my bowls holds 3/4 gallons of water. So what's going to happen to each one of the? How am I going to divide each gallon? I can shade in 3/4. That's a good idea. So I'm going to divide it by 4s, right? So I'm going to divide this by 4s, each one of these. And I'm shading in, and I'm just going to shade like this, that 3/4. I'm doing it again, and I'm shading in the 3/4. I'm going to do it again, shading in 3/4. What is that leaving me each time that's not shaded in? 1/4. So I know this is 1 gallon, right? Or 1 bowl. I know this is 2 bowls. This is 3 bowls, 4 bowls. We can start seeing 5 and 6. Now, where do they get 8 at? Kind of confused. Where do you think the 8 comes from? Do I have some water left that I didn't use in each one of those buckets? I have water left. I have, and how much does it take to fill a bowl? No, 3/4 of a gallon, right? So if this is a 1/4, and this is a 1/4, and this is a 1/4, is that a bowl? So that's a bowl. So that's bowl number 7, and this one is a 1/4, and this is a 1/4, and this is a 1/4. So this is number 8. So that's how I got that. Now let's talk about how do I know that my answer is correct? Is there a way that we can now work this out using another method? Can we actually use just the numbers? Now, if I had this problem, I'm going to be honest with you. I had this problem, I'd be getting some fraction squares out. I love fraction squares for one. But number 2, I love fraction squares because they could really represent this. So I'd be pulling out some fraction squares, or I'd be having the kids to actually cut it up. That's the other thing. I'd be having some paper out there, maybe some cashier's paper. They'd cut up those, they'd label them, or index cards, and then they cut them up and they'd be different color index cards so they could put them together and they could see it. This would be a really good way to do this. So that's part of that CSA model. Like I said, I would have them doing all of that. So with this one, then we would have that conversation of 6 divided by 3/4, right? And we would have that conversation about what's happening there. How many total pieces did we end up dividing this into? Well, 24. And then what happened? How many pieces did I need? I divided it by 3. I got 8, right? I ended up with 24 total pieces. And then I had 8 bowls. We would have those conversations throughout. And then there is 8 gallons of water in the bucket. This one again, but on the 3rd one, I added a question, but I should be adding the question back instead of having it filled in. And the 4th one is the original problem. You just leave it back in there. You just put the original problem right back there. It's perfect for them to be able to do it. But I always add the question back on the 3rd or the 4th one if you do a 5-step. That's one of the things that we want to be able to do. Now, tape diagrams. I love tape diagrams. I'm gonna be the first one to tell you I love a good tape diagram. And the reason I love a good tape diagram is because I used it here, didn't I? You can see this. I can see it on a tape diagram. And what NCTM says about this, and they've been kind of pushing it lately, and if you've seen their article, it's really, really good. It is a rectangular drawing that appears to look like small pieces of tape that we put together, right? And it supports the calculations that's going on. Again, you can see what's happening with the calculations. And I love it. It provides the visual representation. According to research, and we tend not to spend enough time with them doing these kind of drawings, so they don't understand it. According to research, we love to hand them the manipulatives, give them the manipulatives, play with them for 2 days. Oh, you show them the symbols, right? And we totally skip the drawing part. The drawing part is actually what puts it in their brain. When I'm doing those drawings, it actually helps to put it in the brain and really hold on to that mental image that they need to understand how to do that problem. So we have to spend our time with this. Now, a regular ed student in the CSA model, which is, we're going to spend 3 to 4 times, which means 3 to 4 days, doing very similar problems with concrete. We're also going to spend 3 to 4 days. And I said this is regular ed, so we've all got special ed kids, and we all know it's going to take a lot longer than that in the semi-concrete. Now, and then we move to the abstract, which is the symbols. Here's what I'm going to say about that. This is not a linear progression. Okay, I can do this all together, because if I'm working in word problems, what's the one thing I'm going to see every time? I'm going to see the abstract. Those numbers are going to be there, right? But I should be using my concrete manipulatives. Now, am I going to need those concrete manipulatives all the time? Absolutely not. But what I'm going to need to do is I'm going to need to put that semi-concrete. So if I'm working with a concrete manipulative, I may start out redrawing that. But I may move my kids into using different symbols to draw it out, such as they may use tally marks. They may use circles. We may be, if we're doing multiplication, we may be drawing little plates and putting dots on them, right? We're going to do groups, and that's how we're doing it. But or I may be using a tape diagram. Whichever way it works for them, I'm going to make sure that I've got all of this included. Now, we may only be able to do 2 things together at a time, because I just can't hold it all. But if I was going to put 2 things together, I would definitely put these 2 together at first. Then I would move over, and I may try to add in the other, because they're always going to see this part. This may be me doing this part more while they're doing a lot of this. Okay, so tape diagrams, we're going to support that. They're also known as strip diagrams. They're also known as bar models. I mean, they're known as a lot of things, and throughout that they've been known as different things. You're going to gain conceptual understanding, especially from multiplication and fractions. Okay, they're huge for those things. The other thing is they develop reasoning process. We move from the concrete to the abstract. That's the reason I like them. So I want you to try one. My cash register drawer has twice as many quarters as dollar bills. If the quarters and the dollar bills have a combined value of $33, how many quarters are in the cash drawer? So just take a few minutes using a tape diagram to see if you can figure out how many quarters I have and how many dollar bills I have. I'm going to go ahead. I made this a little harder. I know some of us probably teach elementary and we don't have to do this, but we're going to do this. 1, And I wanted you to productively struggle. So what does it say about productive struggle? Makes you better. Why does it make you better? And think about what's something you've struggled with and you really, really struggle through it and you've overcome it. Is that something you're really, really good at now? Or at least you're a whole lot better than when you started? Let's talk about this one. What do we know about, what do you see in this problem? What do you think this right here is? What do you think that's going to be? We're going to do quarters and dollars. Now, what does this word twice mean? Oh, I got 2 times more. So I got 2 times as many what? So this should be my quarters, right? So if we are doing a type diagram, we know we got 2 times as many quarters as we do what? Dollars. What else do we know based on our problem? Has to be $33. What do we know about a quarter? It's 25 cents. How many does it take to make a dollar? 4 of them. So I might have 4 quarters to make the same amount as a dollar. So, but there has to be twice as many of these quarters as there is dollars. So I know a dollar is worth how much? A dollar is worth $1, right? $1. And a quarter is worth 25 cents, but I gotta have 2 of them, right? So how much is 2 quarters worth? 50. So we are looking at, and x is going to be our variable is equal to 33. Now we've come up with this formula, but let's talk about, before we get to the formula, what we need to do. So I can think rationally and say if this is 1, this is going to be 2, right? If this is 2, this is going to be 4, twice as much. Okay. If this is 5, this is going to be 10. So we're going to work through that thinking that way, right? We can do some guess and check at this moment if we wanted to, because we may not know this formula down here, right? Let's hold off on that formula. So let's talk about if this was 10. If this is 10, then my top would be what? Twice as much, 20. So I know 20 quarters is how much? $5. And I know this is $10. So that's $15, right? Use those student-friendly numbers. Wow, that's $15. But I need to be 33. So tell me what you think is going to happen. I'm close, aren't I? So I'm about what? I'm about half. Maybe we need to double it. So let's think about if I double this. Let's say this is 20. So if this is 20, how much is this going to be? 40. So this is going to be 40. 40 quarters is how much?
Well, 20 is $5, then 40 should be $10.
So this is $10, and this is $20. Oh, are we close? We're at $30.
We're getting there.
We're almost there. See how the guess and check method also helps us with this? Lots of good things going on here. So let's talk about now, what am I going to do? I need to get to 33. How can I get to 33 with this? I'm almost there, right there. So close. Maybe one more dollar? Want to try 1? Want to try 2? What do you want to try? Wouldn't go real far, would I?
Because we only need $3.
So how do I get $3?
We need to get one more dollar bill. I do $1.
We need 1.
Let's see, and then you
I'm
have
doubling that.
Would be 42, right?
Is that enough though? So that's going to put you with it has to be 33 even.
Yeah.
So how am I going to get a whole nother dollar up here? I'm going to need 40. 44.
Yeah,
Okay, so,
four.
so I need to make this a 2, don't I? So 44, let's say 404, 44, and this is gonna be 22. Now let's talk about this right here. 44 means it's how much? It's $11, right? So that's $11. And this is $22. Is that $33? It sure is. So now I can say I needed, this would be 22, 22, and 22, because it's twice as much,
Yeah, I
right?
didn't think about that to the end, but thinking, because it's an even number and knowing your quarters had to be in increments of 4, so that helps thinking too. It's like, it's gonna have to either, at that minimum, go up 4.
At a minimum, it's gotta go up 4, because it's gotta be an even number, right? And dollars are always left with an even, so we don't want that. And it would be the same thing as if I was using dimes, right? And I wanted it to be even, then I'm gonna have to make sure it's in groups of 10. So you gotta kind of think that through. Now, Engage New York has a wonderful, and you can get a way to do tape diagrams. So they've got different examples on there. And I just put that on there because, like I said, it's one of the ones I like, I guess, better on explaining it. So I put that link in here, and it's also on the PowerPoint in which you're going to get to. And I think in the participants folder, I downloaded the PDF. And so it's on the PDF if you want it also. So how to use the tape diagrams. Now, I'm trying to think if I have time to do some more, but another one of these would be in fractions. And we talked about, we can talk about this one. And this is Kim has 3/4 of her birthday cake, sheet cake left after her party. Her friend Lisa wants to take 1/5 of the birthday cake home. How much of the whole cake did she get? Now, again, we're working with the whole there at the end. But again, if we wanted to look at that, and we'll just go quickly through that, what could that look like? Now, again, if I'm using the CSA model, let's talk about that. If I'm using the CSA model, the first thing I would do is pull out either fraction squares, or I'd pull out some paper that they can cut up. So if I have a sheet cakes typically look like this, right? They're usually rectangular. And we said that she has 3/4 of it left. So we know if I'm dividing it into 4s, she has this much of it left. Now, how much did she want to take home? How much did Lisa want to take with her? She wanted to take 1/5, and it's hard for you guys to see, I know. She wants to take 1/5 of it home. So what do I need to do now? I need to divide it into fifths, don't I? Well, you know what the great thing about dividing is? You go the other direction. So if I went this way to divide it into 3/4, I'm going to divide it into 5 pieces this way. We had those conversations about, now I've divided that cake, right? Now we know this is all that she is left, and she's wanting 1/5 of the leftover birthday cake. So she's wanting this section right here. She wants those 3 pieces. Because remember, these were 8 at the party. Right? That was 8 at the party. Nobody gets those because they're already gone. Soon, gone away. But she was wanting 1/5 of what was left over of the birthday cake. But of the whole cake, how much did she get? How many pieces did she get? 3. She got 3. And if I thought about the whole cake, the entire cake, how many pieces could that have been? 20. So she got 3/20 of the cake. So if I had cut up my cake, this is what she would have got. So that's just another way, like I said, for us to be able to use is to show the CSA model, pull it through. I would use, like I said, fractional squares. I'd have them cut it up. I am not above cutting up foam squares if I had to, for my kids to be able to see it. Kim and her friends are going to have a girls' night. Okay, she's decided to make snacks. Again, if I was going to do the content scaffolding progression, this whole sentence here would be gone, right? I'm thinking content scaffolding, that's gonna be gone. I'm gonna say that Kim is making sandwiches for 5 of her friends, right? She's making 3 sandwiches each. You know, but if you think that she's making sandwiches for 5, how many people are actually there? This is what our kids don't think through. We have to have those conversations. How many people are actually at this party? Kim and 5 of her friends. So how many people are actually at this party? 6, because it says she's making it for her and her friends, right? So we got 6 people at this party. Each person's getting how many sandwiches? 3. I can do a tape diagram real quick with that because I know I need 6 people. 2, 3, 4, 5, and 6. How many sandwiches does each one of them get? 3. So I can do 3. How many am I going to need by here? 6, 9, 12, 15, and 18. If everybody gets 3 sandwiches. See how quick that was for my kids? And they can put it right in there if we needed to. Could I put 3 dots on each one of them and then they count them up? Absolutely. Could I put 3 counters in there if that's what we needed? I can. The other one is I use 4-H. Our kids love 4-H. They talk about it all the time. 4-H is a wonderful thing for our students to have. So we're doing Band-Aids. One of the things that you get when you're a counselor is you get a little bitty bag. It's got all your stuff in it that you need, Band-Aids, creams, those kinds of things, in case kids come to you. And so I use Band-Aids. Something they know and something they realize. Again, we've talked about the CSA model. One of the things that Joe Bowler says is mistakes and challenges are the best time for your brain to learn. Again, productive struggle, right? It's okay for me to make a mistake. Sometimes as teachers, we need to make a mistake so the kids can catch it. And that's okay too. Most of the time, I didn't have to pretend to make a mistake because I already made it. You know, it's one of those things. The kids will catch it. It's real good. Some days, especially by Thursday, your brain's a little tired too. So that's all I want to say. Productive struggle is truly productive. Don't make it so hard though that the kids go beyond productive struggle. I want them to have productive struggle, but not to a point that where struggling becomes an issue and they shut down. Those are things that happen when we don't allow, again, for that gradual release, for that scaffolding that they're going to do. These are some things, these are resources for math talks. Now, all this time I've been saying they need to talk, they need to talk, they need to talk, right? So some of the things that you can get, that you can have them to talk through, and my favorites are Estimation 180. It's a really good one. Robert Kaplinsky's lessons are fabulous for those kind of things. Math Talks Images, or has anybody done the ones that are what doesn't belong? There's multiple ways to do these, but I love them. And I'm gonna pull one up real quick. So which one doesn't belong? This is the site that you're gonna go to. Let's look at this one right here for numbers. This one right here. Let's do the 9, 16, 25, and 43. Which one doesn't belong? Let's have those conversations. Nine, 16, 25, and 43.
Well, right off the top, I'm gonna say 9 because it's the only 1-digit number.
No. 9 is the only 1-digit number. What else? I'm gonna say 43. You know why I say 43? Because this is 3 times 3, 4 times 4, 5 times 5. Do you have one? Could be 16. Why could it be 16? 16's even. All the other numbers are odd. Could be 43. You know why it could be 43? Because that's a prime number. Do you see all the things that could be there that I could talk about with that? Like you said, that could be 9, could be this one. What else? I have stumped her. I love these things because there's so many things that we can talk about.
Yeah.
You know, there's multiple ways that I can look at this and I can talk through it, and I love that for that reason. So,
Really get you thinking. I mean,
and my kids can
It
argue.
does start some good conversation also when they have to explain why why their answer. And then it's like, I mean, you never thought about it that way, or if you can see other point of views and then, so, yeah.
And my kids can argue about it, right? Like, they can have that conversation. And guess what? That's one of our math practices. They got to be able to construct a viable argument. And so we want them to be able to do that. So that's one of them. If I go back to this, I'm going to say another one is math mistakes. My favorite no. Now, I am going to say this. If you use my favorite no, and you got a small group, because I had small groups, right? I had no more than 8 in most of my classes. But if you got a small group, rewrite your my favorite no, and there'll still be a kid that goes, that's mine, I did that yesterday. But rewrite it, because kids do know each other's handwriting, believe it or not. But my favorite no is one of those, and I would bring it up and I'd say, this is my favorite no, and I would just explain why. And one of the reasons why is the kids are like, oh, I did that, or I did something similar to that. That's why I shouldn't have done that. And so it also makes them say, well, I see this in the problem, but they didn't do this. And so they have to correct somebody else's problem. I love those, my favorite no's. Open middle is another good one that you can do. Fraction talks, if you like fractions. I like fractions, but fraction talks, and it's a little harder. Number talk images, just giving them images. It's just an image, and we have conversations around that, kind of like the subitizing. So those are really good ones that you can do, that you can work through. Graphing stories, I love it. If you've got older kids, because we have to be able to read graphs, right? And science is 90% of graphs, so see, we're getting that connection between those two. That helps out too. So having those conversations that you would need, visual patterns, they need to be able to connect patterns. This, what we did here, was connecting patterns. All of these things help us, especially patterns, helps us with them being able to start to explain things. So having some resources for you to use will help. Like I said, I know today I gave you 2 things. I gave you content scaffolding progression, and I gave you a tape diagram to use for word problems. But those 2 things really help us, because I wanted to talk about what that CSA model would look like. So getting those manipulatives out, working with them, doing those kind of things, and then also having them to do that visual part is very important for our students. Good stuff, guys.